We're taking a certain amount of chemical in grams, converting that to moles, converting that into a different chemical based off of a chemical formula, and then taking that and converting back into grams. So my abbreviated step-by-step instructions here are to go from grams to moles, then to go from moles to moles, and then moles back into grams. Steps 1 and 3 are pretty easy. They're just simple mole to gram conversions using the molar mass from the periodic table. But the middle step, you have to use the ratios found in a chemical formula. The chemical formula is right here. C3H8 plus 5O2 yields 4H2O plus 3CO2. And my problem says if I'm given 14 grams of O2, how many grams of C3H8 will I need to perform this reaction? So just like normal, we take the number we're given in the formula here, 14 grams of O2, and we set up our conversion factor. Whatever unit is here, we move diagonally down. So this is going to be grams of O2 down here. And first step is to go from grams into moles. So we're going to put moles of O2 up top. This number will always be 1 every time. This number down here comes from the periodic table. And the molar mass of oxygen, O2, is 32 grams. I found that by finding the molar mass of oxygen, which is 16, and multiplying that by 2. Once I've done that first step, I can go ahead, use my calculator, and do the math, multiplying on top, dividing on bottom. And my answer for this one is 0.4375 moles of O2. I know that it's moles of O2 because this unit was canceled and this unit went with it. That's step 1 of stoichiometry. Step 2, I'm going to use a different color for here. Step 2, you're going to go from moles to moles. This is the step that's new for most students, but just like last time, we take our units right here, we move them diagonally down, moles O2, and then up top we're going to have moles as well because we're going from moles to moles. But the difference is you have to look at your problem again and find what chemical they're asking for in the end. C3H8 in this case. Now, the problem is what numbers go here? Well, the way we find that is we just look at our chemical formula up top. And whatever our coefficient numbers are, and in this case there's an invisible 1 right there, whatever the coefficient number is, that's what goes in the blank. So this should be a 5 from the formula here, O2, and C3H8 will have a 1. Now, we're going to do the same thing we did last time. The units are going to cancel out. We'll multiply on top, divide on bottom. And if you didn't clear your calculator, this is really easy. And so now we have 0.0875 moles of C3H8. That's step 2 of stoichiometry. Step 3 is going from moles back into grams. And this is another one where we just use the molar mass found on the periodic table. So we need to find the molar mass of C3H8. So we're going to go 3 times 12.01 for carbon and 8 times 1.01 for hydrogen. And when we add those up, we'll get the molar mass of C3H8. And the molar mass of C3H8 is 44.11. We'll draw our crosshairs here. The units move down diagonally, moles of C3H8. Then we're going to put grams on top because that's what we're trying to get into. This number that we found, the molar mass, that goes right down here, 44.11 for every 1. This times that divided by 1. And our answer to the whole problem right here is 3.8596. This is rounded without significant figures, grams of C3H8. That's how you do stoichiometry.